Hi everyone. Today video is on CQRS and mediator pattern. So in this video we are going to create a .NET 5 web API application. Okay. In that we are going to implement CQRS pattern by writing some queries and commands. Okay. So the name CQRS stands for command query responsibility segregation. Okay. So how it looks like CQRS. See, CQRS main target is to separate the commands and queries. So what are commands? Commands are operations to update or save a record to the database. And queries are nothing but to fetch the data from the database. Okay. Why to separate them? So if we, uh, if you do them in like a single business logic layer, there might be a use code and there might be a dependent on one another, and also same data object might be used for fetching the data and saving the data. Okay, which might contain two extra properties depending upon the operation kind of operation. So to avoid them, to make them individual or to separate them cleanly, this CQRS will be helpful. Okay, and this CQRS will contain response model and request model. Okay, so each of these response model, request model will be designated to single operation only or owned by the single command or query only. Cannot be shared between commands or cannot be shared between queries or cannot be shared between a command or a query. Okay. So one DTO class or a model class or any POCO class to use it for data transmission can be used with only one operation only. Okay. So if you observe this image, you can observe here inside of the command box, I have uh, created some tiles like request model and response model and commands. Okay. But if you observe, response model is optional because in commands mean what? Updating or creating the data into the database. So in this case, we might not need entire object to be written to the response, or we might only return a ID of the record like integer scalar type, or sometimes we never return response in some cases. So in this kind of commands, response model will be a optional because we won't create a separate class for response. Okay, let's look into the queries. Queries also same structure like a request model, response model, and query command handler. Okay, but here request model is optional because sometimes we no need to have a object at all for the request while reading. We might sometimes we might use two or three query parameters. Then also we might not to create a separate class. If there is a huge number of query data, then only we are going to create the request model. Okay, so that is why here request model is optional. Okay? So this is how CQRS uh, structure will be look like this. And I also want to show the folder structure how it looks like. So this is the CQRS folder structure. So how it more core components are nothing but the handlers. See here handlers. So handlers contains the logic to communication with the database or any business logic that you want to implement. Okay. So here handlers are divided into two types: command handlers and query handlers. Command handlers are going to handle the logic for updating or creating data into the database. Query handlers are used to fetching the data. Okay, this is the core handlers. Next, you can see the request model and response model, two different folders. And inside of the request models, there are models for comments and there are models for queries as well. Similarly, in response model also, command, command response model and query response model. And here top on you can see contracts, nothing but the interfaces. Those are for the our handler command or query handlers interfaces will be written here. So this is how we are going to separate our files or logics into the folder structure. So this is how the CQRS folder structure looks like more or less. Okay, so let's jump into create a sample application. Okay, and we will implement CQRS, and later once we completely understand the CQRS, next we can add an enhancement with the help of another design pattern like mediator. Okay, and finally we will close the video. So let's jump into creating the .NET 5 Web API application. So let me create a sample project. So .NET 5, I'm using CLI. If anyone using Visual Studio, those who are using Visual Studio, please make sure to have .NET 5, sorry, Visual Studio 16.8 point something, the latest version, because below that version, .NET 5 cannot be built in the Visual Studio editor. Okay, so let me create my project. I need to name my project like and one more thing I forgot to mention. This entire session, whatever I am going to explain, has been already made as a blog. So the link of this blog will be available inside of the description under the video. So who are interested to look into the blog, you can check in the description. Okay. I'm going to use Visual Studio Code Editor for my development. So here is my project and its target framework is .NET 5. Okay. So here we are going to implement a simple application with some command and query operations to understand the CQRS pattern. Okay, so for this application, I have already created a table like products. Okay, so what I will do, I am going to implement code first with existing database so that we can easily enable the communication between the database and our API project. Okay, so to make it quick, code first approach technique, I hope it is very well known approach to everyone. Okay, so to make it quick, I'm going to implement it by copying from my snippets. Okay, first, and to integrate NT framework code first approach, I need to have two NuGet packages like NT framework core and the SQL server extension for NT framework core. So first, let me install them. Okay, I am copying CLI command. Visual Studio users copy it from package manager. Install it. Here you can see the package reference added to our CS project file. Now another NuGet I need is SQL server. That is the extension for our NT framework core. So let's copy the command and install. So you can see the SQL server extension for NT framework has been installed and reference is added to our CS project file. Okay. So let's integrate our code first technique files. I'll create folder like data, one more folder inside of it entities. I have mentioned I have table a products, right? So I'm going to add entity for the products table. So let me copy here and create a file like products. So here, let's copy paste our snippet. Okay. Now let me create a database context class in data folder. I will name like so. Let's copy our context snippet here. Okay. Let's import some namespaces. Okay. Now let's add connection string to our database into our JSON config. Okay. Finally, let's register our DB context into the startup file. So that's how we finished our integration of code first technique into our application. Okay. Now let's create the folder structure that I have already shown you for CQRS. So main thing in CQRS is handlers. So let's create folder like handlers. Okay. Inside of handlers, we are going to have two folders like one is query handlers and another is comment handlers. So query handlers contain data fetching logic and command handlers contains uh, like data updating or creating logic. So let's have two folders like command handlers and one more folder like query handlers. Okay. Next thing is we need to have a interface folders for this handler. So what I will do, I will create a folder like contacts which contain abstract method definitions. Okay. Inside of it, two folders like command handlers and one more folder like query handlers. Okay. And next we required is request models and response models. So first let's create response request models. Create a folder like request models. Inside of it, again two folders, command request models, right? For these request models belong to command handler. And one more folder is like uh, query request handlers, request models. Query request. Okay. So now we have to create about response models. Let's create them. response models, and inside of it, uh, command response models, and one more folder like query response models. Okay, so I think we are done. So let's have a brief look what we have created. We have created handlers and its interface folders and request and response model. Okay, so let's begin by creating a command to save the data into the database. Okay, so for that, in handlers, under the command handlers, let's create a handler file like save product. Okay, command handler. Okay, this is our command handler class. Okay, so each entity or a class will have only one responsibility, means one command, either one command or one query. So here this class contains command like to save the record to the database. Public. So let's inject my database into this uh, class. So before that, let's first create the interface. That makes more sense. So in the folder hierarchy like contracts, inside of the command handlers, let's add one interface class for our save products. So this is our save product command handler interface. So let's define a method definition. So after saving the record, I just want to return scalar type, nothing but integer, which is a record ID. So returning a scalar type means we are not creating a response model. Means in this case, we don't require a response model. So int and save. Now I want to have a request model because here save need to post some data to the database. Means we need a request model. So to fulfill our method definition, first we have to create a class for our request model. So where we have to go, this is for request. Go to request and this is for command. So under the command request models, we need to create a request model. So my request model name is like save. Okay. So this request model only will serve for this save product command handler. No other handler should use it because CQRS is that separation and segregation. So this is my request model class. So it will contain properties that are in our products class, table class. So I no need product ID in my case because I am going to create new record, right? So this is the one of the advantage of CQRS because this class doesn't contains ID. For suppose if the same class you want to use for fetching the data, then you definitely need a ID and you might not require few other properties based on your business scenario. So the main idea is the data transfer objects will only contains that are respect to their operation requirements. Okay. No one extra property or less property will be created into these kind of classes because each request or response models will be designated to one operation only. Okay. So this is our, I have, sorry, this save product request model. Okay. Now go to our interface, handler interface. Here I can specify my input request model. Sorry, little bit confusion. I have copied properties into the handler. Close it, and my request model is here. Okay, just pasted in handler class instead of a request model class. Please correct it. So now I can import. So this is my method definition. So let's copy our interface class and go to our implementation handler, that is save product handler. Let's import inherit it. Okay, and let's implement the definition now. Okay, so let's remove this default code, and in this save product command handler, first let's inherit my database context. Okay, now copy the request model data into the table object. So let's save this data into the database. So let's use asynchronous calls. So for that, what I will do, async, and also change our method name to appropriate to async task. So let's update in our interface as well. So finally, let's return the new product ID. Okay, this is our command handler logic will look like. So what we are doing, we are saving the new record into the database, and its request model, it is like this. And it don't have a response model because we are simply returning the scalar type. Okay, so if you go to our diagram, this is command, right? We have command handler, this box, and response model. I have told optional because we are returning scalar type. And next is request model. Request model is here. So, and this is a separate file for only this operation. So here we are fulfilled our CQRS command handler, right? So next thing is we need to register them in the startup. Right now, let's add a new controller, okay, like products, and create a endpoint to uh, invoke this save product command handler. Okay, let's create a new controller like products controller. So this is our products controller. Let's create an endpoint to save the records by invoking the save product command handler. So first I need to inject the save product command handler into my application. So this is my endpoint. Okay, like route I have defined like create, and here request model. Okay, payload object, and invoking the save product command handler and returning the result, which is nothing but the ID of the record. Okay, now let's run and test our endpoint. So here you can observe our endpoint in Swagger. Let's execute it. So I will create product name like man. Okay. So let's uh, push it into the server. See, I have got ID as a response from my endpoint. So we have successfully done with our command to saving the record into the database. Okay, and let's have a look at our folder structure after creating the files. Let me expand. Okay, expand. Okay, so how our command handler looks like? It will have an interface. Okay, and it will have a save product command handler. Okay, and the request model. So this is how our file structure once we completed our command handler. Okay, now I want to create a query. Query means fetching the data. So what I want to do, I want to fetch all the data from my database. Okay, so for that, let's first define our contract handler. So then we can add abstract method definition there. So it is in contracts, go to query handler folder because this is query, right? And my interface name is like all products query handler. Okay, this is our interface. Now I need to define a method in it. So here, what is our goal? To fetch the all records from the database. Means collection of records from the database. So here my response model is like collection of products records. And since I need to get all the records, I no need to have the request model. So let's create the response model first for our query handler. So for that, what we will do? Response, right? Go to response folder. Under that, go to query response. Here, add a new class. So this is our model class. So it will contain all the properties of my products table class, including ID also, because it is response, right? Reading all the records. So let's paste it here, including product ID also. We will save. If our business is to save only like read only product name and ID price, then we no need to create the additional properties. So main rule here is never create one additional property also if your business doesn't require in the request or response object. Your wrong name I have given, it is so just so now we have to define our definition in IL products query handler. So we expecting list, right? List, and what is our response model? All products response, and I will name like get list link. No, no need to have request model here. Okay. Now we need to implement our get list async of all product query handler. So let's create a query handler. The handlers folder, under the query handler folder, add a new class. So this is our all products query handler class. So let's inherit our interface. And let's implement the method. Okay, let's remove it. And first is first, let's inject the database. Okay, now simply we need to return the collection of products as all products response model. Async task. So let's update the definition as well. So this is our query handler finally. So whatever we are having here, this query handler doesn't contain uh, request model, but it will have response model. So once go to our diagram, in queries, request model is object and response model and read, right? So we have completely satisfied this picture. Okay. So now let's register our handlers in the startup file. If you observe, till now we don't have dependent one operation models or logic keys doesn't depend upon other model operations. So it defines our segregation in the CQRS. Okay, now let's define a new endpoint to test these results. The product controller. So let's inject those handler, query handler. So this is our endpoint. We are just fetching the results from the all product query handler. So let's test it. So here is our new endpoint. Let's test. See, I'm getting my all products in my database. See, this is the latest one we have inserted using our command, right? And so that's it. We have created one command and one query to understand the CQRS. Okay, let me create one more query to get more familiar with query handler. So that query handler is get the collection of products, but based on the query parameters. I will use price range. I want to get the data within the price range. So for that, let's create one more query handler. So let's create the interface to define the definition of a method. So what we will do in the contracts, and it is also query handler, right? In the queries, let's create the interface. So this is my class name. So here is our high price range product query handler. Now it will contain a method to fetch the results based on the price query parameters and the response. So here in this approach, we should have response model. Okay, and the query parameters you can use normal scalar input properties to the method, or else you can create an object for it. Here I am going to create normal scalar properties instead of a model. So first we need to define the model for response model, right? Because we will get collection of response data. So for that, what we have to do? So it is for response, right? Go to response folder, and it is for queries. So here create a new class. So this is our query response model, that is price range products response model. So let's go to our products table. So let's copy properties. Paste it here. If you observe, here also fetching all data, and in previous model that is all properties. Okay, having same business rules, right? Meaning all need to fetch all properties, but never use a single class for the two operations. That is the rule, right? So we need to create another separate class. Okay, that is the CQRS pattern. And now go to our uh, newly created price product. Okay, here we need to define our definition, like price range product response model and get list SC. And here we will have query parameters like int min price, int max price. And it should be asynchronous. Okay, let's implement logic for this get list as async method. Go to our handlers. In that query handlers, let's create a new query handler class for price range query handler. So this is our handler class. Let's inherit our interface and implement the method. So also inject the DB context. So this is our DB context. So this is our DB context injected. Should be async. So defining the price range logic. It should be await. So this is our logic for our handler. So here we are using input query parameters and the response model in the handler. So let's register this handler in the startup. And now let's create a new endpoint for this price range products query handler. And first let's inject the handler into the constructor. So let's define the new endpoint. Okay, this is our endpoint to filter the data based on the prices. So here you can see our new endpoint. Let's try. See, now I am able to filter the data, right? So that's all we have. For understanding, I have created additional query. So we have done implementing CQRS into your sample application. So we have separated the queries and command as individual handlers with their own respective request and response models as well. Okay. So you can observe there are few drawbacks like having multiple classes and constructor injecting with all the required handlers, right? So the individual classes we cannot do anything. It is like that only request and response models. Okay, but here we can reduce the boilerplate. Okay, using the mediator. So let's see what is mediator. Okay, so mediator is also another design pattern. Okay, it is mainly like message broker uh, approach. But it also deals with commands and queries. So here in the mediator, it's mainly depends on request model. Okay, so based on the request model, the respective handle will be triggered. Okay, like a messaging queue. Okay, based on the request model, the respective handler will be triggered when we are using the mediator. So from this we can conclude request model is mandatory while using the mediator. Okay. So and also it is the best recommended pattern to combine CQRS with mediator. Okay. If you observe the diagram here, mediator will act like a centralized hub for invoking the handlers and fetching the response from the handler to the controller. So it is like a centralized hub. Okay, where request and response of the logic will go through it. Okay, and if you observe the here models, request model means user defined, nothing but a class. Means it is mandatory because based on the request model, a response will be invoked. Sorry, request handler will be appropriate request handler will be invoked. And response you can see either it can be a class or a scalar type. Similarly, for queries also. Okay, this is the use of and a brief overview on the mediator. Okay. Now let's check how mediator will help into our CQRS pattern architecture. So let's install few nuggets for mediator. Okay, let's first install this mediator. Okay, copy the command, install it. So reference is added into our project file. We need one more mediator file like dependency injection that supports dependency injection. You can click the second link only, mediator extension for Microsoft dependency injection. So let's install this as well. So mediator extension for dependency also installed. Okay. So what I will do, first I will change the integration of mediator for our command handler. Okay, we will update step by. We have implemented 3 operations, right? Like 2 query handlers and 1 command handlers in CQRS. So we will convert all these 3 into mediator approach. Okay. So this is our save command handler, right? Okay. Here we have request model like save product request model. Okay, I have mentioned mediator depends upon the request model. Okay, so based on the request model only, it will renders the appropriate handler. Okay, so here while using mediator for our request model, we need to inherit one interface like that is from mediator, and that in I request should contain the type of our response. Okay, what is our response? Integer. So we need to define it here. Okay, this is the first step. Any request model should inherit this I request, and we need to define the type as response type. Okay. From this, we can conclude that while using mediator, we must have a request model that should be a class, and we should have response model that should be either a class or a scalar type. Okay. Next thing is we need to change here in save product command handler. So what I will do, I will comment entire logic, entire this class. Okay, let me create a same class again. Okay, now to automatically invoke this save product handler, we should inherit one mediator interface like, and it should contain our request type and response type. What is our request type? You know, in this method, this save product request model. So we need to define our request model, right? And what is our return type? Return type is integer. Okay. If you see here also, it expects input request, that is request model and response model, the I request handler. So now we need to implement one method like handle. So implement it. See. So this is the method automatically triggered from the mediator based on the request object. See, it is request property also automatically injecting into this method. Everything taken care by the mediator when we pass the request model to it. Okay, here we can inject our database context. Okay, And let's copy the logic from our commented code. Okay, simply change the variable name. That it should be async. So that's it. We have changed our uh, handler as per our mediator requirement. So what is mediator requirement? First thing is our request model always should inherit I request and it inside of it, and its type should be defined as response type. Next, handler should inherit I request handler, and there we need to specify our request model and response model. And next we need to implement the default handle method. So our handlers will contain only one public method. Okay, that is handle. Now let's register our mediator into dependency injection in the startup file. Okay, services dot. Okay, and we just load the assembly file. It will automatically load all the dependency files that it requires, like I request model or our handler objects. Okay. Now what we have did, we have implemented the mediator for our save query command handler. Now we no need to create interfaces for each our individual uh, command or query handlers. So I just comment this line, which is I save product command handler interface. And also I need to comment in my controller as well. And I need to inject the mediator. Okay. And change our action method. So mediator is a messenger type architecture. So here only one method will be used everywhere. That is mediator.send. Inside of it, we need to pass our request model. So this is why request model is mandatory. So what is my request model? Save products. I can pass it. Sorry, variable name. See, that's it. So based on this request model, it's appropriate command handler. What is that command handler? This one will be invoked. Okay. So that's how it works. So let's try to add a one new record because we have just changed it to mediator, right? To test it. So let's run the project. So let's create new record. Like, okay, let's execute. I'm getting some error. Okay, I haven't. This send method is asynchronous. Missed await. Okay, let's try to save again. Okay, let's save it. See, now I am getting 200 response with the response ID. Okay, so we successfully converted our save product command handler with the combination of mediator. Okay, now let's uh, change our one more handler, that is all products query handler. Okay, so let's change it to mediator support. If you observe with the existing code, we don't have request model, but we should have request model for mediator. So what we have to do? Nothing option. We need to create a empty request model that is mandatory for a mediator, and that class should inherit I request, and it should define its response type. So what I will do, I will create a all products request model, empty one. So request, right? Go to request and queries, add a class like all products request model. So there is nothing input data for this model. This is creating for the sake of mediator to invoke the appropriate request handler. So only thing is we need to inherit I request, and here we need to specify our response model. What is response model? List of all products. So copy that and define it here. Okay, that's it. And now update our all products query handler. So let's comment this all code. Okay, now write code using mediator. We know it should inherit I request handler. And we need to specify our request model and response model. So what is our request model? All products request model. What's its response type? It is a list of all products response model. Okay. Let's inherit any namespaces that are required. Now implement the handle method. Right. So remove this. Now inject the TV context data. Okay. Now copy the code that we have already written previously. Okay, and it should be async. Okay, so that's it, our changes for our handler. Okay, now what we have to do, we know that we can remove the all product services. We no need to require the contracts. I'm removing step by step, but if you understand, you can delete this entire contracts folder because we no need to have, we cannot have now the respective interface for the handlers because they will automatically depends upon the I request handler. And now go to our products controller as well. So comment out this all products. We no need anymore and change our all products. So where result equal to await mediator send and new. What is our request model? All products request model. Let's pass the instance to the mediator. Okay. So that's it. Our changes for the query handler using mediator. So let's test it. Which way change products all. So let's try and execute. See, I am able to get the data. So we have finally understand the how to create the query and command handlers using the mediator. So let's also do our one more pending query handler to mediator as well, so that we can close this video. So let's go to this query handler. So where is that handlers? Price range query handler. So here also we are fetching data from query parameters, right? Request. So we need to change them to the response model type. Okay, sorry, request model type, because we must require uh, request model. So let's create a new request model for this price range query handler as well. For that, go to request models, and in the query, let's create a new class. So this is our request model. It should contain properties like, okay, what it should contain. Min price and max price properties. So let's create those properties. And we know our request model should inherit high request. And its type should be our response, which is nothing but the list of price ranging products models. Okay, now let's update our query handler. So let me comment this class existing code. Let's create new one. Okay, we know it should inherit high request handler. So here we need to define our request model, then the response model. My request model is this one, and response is this collection of pricing products models. So let's import it and let's implement the mediator handle method. Okay, let's copy the context. Okay, and let's copy the old code for returning the response based on the filtering. It should be async. And here we need to change it this from request model. So that's it. So that's it. We have completed our implementation of this query handler as well. So in startup, let comment out that interface, and in the products controller, remove that interface. Okay, everything is taken care by the mediator only. Invoke in the values. So here I can change. So here we need to define the read the query parameters as the object. Okay, from query, and that is nothing but our this model. Okay, where result equal to await underscore mediator send and request model. Okay, save all, and let's test this filter range as well. See, we got the result. So we are successfully done with the implementing CQRS with the help of mediator. So let's see the full controller, how it will look after we integrating the mediator. I am zooming out. So this is my controller. Constructor need to only inject the mediator only. Nothing is required. So mediator will reduce the some boilerplate code what CQRS actually have. Okay. Okay. I think that's it. This video has delivered some useful information on how to implement the CQRS and mediator in the .NET 5 application. If you like my video, please do subscribe to my channel and we will meet you again with the new videos. Until then, signing off.